Hello again. So we are going to continue with graphing linear equations. And before we actually get into anything new, let's review. So what is a table of value? First of all, a table of values. Table of values is just a sample. I just want to make sure that it's only a sample of many x values that you can come up with that you actually can use to get more y values so that you can actually create a data set. Now, how many is good? Well, depending on the situation. Now, does it make sense to find or come up with 1,000 values for a table? No, because it's going to take us years to finish a problem. So, depending on the situation, you go between anywhere between 3 and up. So, and remember that this 5 is basically the minimum, but again, that even depends on what is it that you're looking for and depending on the problem. Now, not all data sets and table of values, they give you a line. They will not give you a line because later on in higher grade, you realize that different table of values, they give you a different type of relations that they actually give um, they give rise to different types of graph, not linear graph, not a line, but a curve, different types of curve. So it's very important that you realize that you do need many data sets or many table of values, but not as many depending on the situation, and you go from there. Now, a couple other things. The other one is we need to know what is a discrete value and continuous values or data. So, and that's very important. And very simply, discrete values are the values that are whole numbers. No decimal, no in between numbers, no 1.5, no 2.8, no 8.9. I'm giving you a few numbers here as an example. And the real life example of that is that, for example, you cannot have, in terms of peoples, you cannot have half a person or a 1.5 person or 8.9 people. You cannot have that. Either 1 or 10 or 20 or 100 people you can have. And that's called discrete. That means they are whole numbers. All right. Then the other part of that is continuous values or data. And in this case, you can have any type of data set, any numbers that are small, large, in between, decimal, fractions, doesn't really matter. And a perfect example of that, for example, my height. All right, and in centimeters or in feet or in can be in decimal. So I could actually be 1.3456 meters, or I could be 5.625 feet in terms of height. And so the height is an example, so as the weight, and you can come up with many, many other ones. So the continuous variables or values are basically everything, all real number system that are part of the data. So it doesn't really matter what you choose as long as they are part of the real number system. Okay? All right. So let's start with the example. This is a typical example. The cost C in cents of making n photocopies, just a typical photocopier that you go to a Staples or you go to any type of a office supply place to make copies of certain documents. That is given by a formula. C, the cost, equals to 50 plus 5 times n, and n is the number of photocopies. All right. So the first thing is that let's make a table of values showing the cost up to 100 copies. Simple as that. We're just going to make this table of values the way we have done with the x and y, but in this case we have n and we have c. That's your x and y, okay? So this is your y and that's your x if you want to look at it like that. So let's go ahead and we're going to use the intervals of 20s to come up with these. But 5 data points, 50. 5 data points in this case suffices for this problem. So let's do that. That's 100 copies. So we're going to stop at that. So we're going to plug numbers in one at a time. So here it is, 50 plus 5 times 20. We're going to do the math and we're going to come up with a solution. So we're going to do that for each one of these guys. So we're going to pause this video now and do the math and come back to it. Okay, so once you go through each one of these, you're going to get 150 cents, 250 cents, 350 cents, 450, and 550. Now, remember, we chose in this question, I chose the 20, 40, 60, 80, 100 copies. But if you really wanted to, you could do from 1 to 100. You can have 100 data sets, okay? But 5 will suffice in this case, so you don't need to do 100, all right? So now that we have these values, we're going to go ahead and graph. So part B will be graphing. All right, so we're going to make a grid. Now notice that the grid that we have, it's basically positive values for each of the x and y axis. In this case, actually, x-axis is the n value, right? And the y-axis is the c value or the cost. And I put the actual labeling right there. Number of copies is on the horizontal axis and the cost is on the vertical. And you know, you can partition the graph any way you want, or the grid. So in this case, I just chose 20, 40, 60, 80, 100. But you could use the entire graph paper and do a massive graph and put that and make a large kind of a graph, and that is totally fine. But in this case, this is good. So let's go through that. I partitioned the vertical axis from 50 and then go up every 100 for 4 squares. So from 50 all the way to 550. And now we're going to basically plot what we have. And now remember, you're plotting all of these ordered pairs that we have learned from the beginning. So the first one is 20 and 150. Where is that? That's 20. You go up 150, that's your first coordinate right here. Let's call that A. All right, and then keep doing that for the rest and then come back. Okay, so all the coordinates has been done. So the next one will be the C coordinate, and I plotted it already, 60, 350, and the D is AD 450, and the last one, A, B, C, D, E, and that would be actually E, capital E. Let's do capital E, and that's a capital E right there, and that is 100, 550. And here are the actual coordinates right there. Now we're going to go ahead and draw a straight line through all these points. All right, so here it is. That's the straight line graph, and make sure that there's an arrow at the end, even though we are starting at 0 copies, so we can go into a negative area. So notice that this grid is only a positive value for each one, because we cannot have a negative number of copies, so that doesn't make sense. The other piece is that notice that these are actually discrete values. So discrete values, remember what we talked about, discrete values, discrete and continuous. We're back up there. Discrete right up there, right here. This is discrete right there. So that is discrete. Why? Because we cannot have half a copy of photocopy of something, either the whole copy or no copies, right? So these are discrete values. Great, we know that. So these are discrete values. And we connect them, even though really technically we shouldn't, but we can. In this case we can. Now the reason we shouldn't connect them is because we cannot have, again, a non-discrete. It's not a continuous. So but in this case we can, and then we're going to go ahead and just come up with other information using the graph. All right, let's look at an extension question. I just put it in there. See, what is the cost of 50 copies given this graph now? Now we're going to use the graph, right? So you're going to come up here, you look at, okay, what is the 50 copies? This is the 50 range right there. Then you go up all the way straight up until you hit the graph, and then you come across and you notice that, oh, look at that. This is right there. So if it has 250, that has to be 300. So the cost for 50 copies, here it is, let's do it again. 50 copies is 300 cents or $3.0. All right, and it does make sense. You plug in 50 into the original relation right here. If you plug in 50, so that would be 50 plus 5 times 50, and yes, that would give you 300. So we are okay and our graph is accurate. And that's how you actually can extrapolate more information from this graph using the data table of values and then the graph together to come up with more information as you need it. Okay.